Higher College of Technology, Fujairah Men College, Mechanical Engineering Division, MCE 2223 Applied Dynamics, supervised by Dr. Amjad Sakan. Rectilinear Kinematics, problem 12 to 25. A sphere is fired downward into a medium with an initial speed of 27 meters per second. If it is experienced as a deceleration of a minus 6t meter per second square, where t is in seconds, determine the distance traveled before it stops. Given from the problem, the initial speed is 27 meters per second. The initial distance is 0. The initial time is 0. Because nothing was given regarding the initial displacement and time, so it will considered as 0. The acceleration is equal minus 6 meters per second square as a function of time. Velocity equals 0. It understood from before it stops that the final velocity is 0. The required final distance. The solution. Because the acceleration is given as a function of time, you should integrate it to final velocity equation, then integrate the velocity to final distance. Acceleration is the rate of change of velocity with time. It is expressed as a equal dv over dt. Rearrange the equation to have dv on the left side and acceleration as a function of time on the right side. Integrate the both sides, dv from initial v 27 to v, dt from t equals 0 to t. After the integration, you will have v equal 27 minus 3t square meter per second. Substitute v equals 0 in the equation to find the time. After integrating the acceleration and finding the velocity equation, now you should integrate the velocity to find the distance. Velocity is the rate of change of distance with time. It is expressed as v equal ds over dt. Rearrange the equation to have ds on the left side and velocity as a function of time on the right side. Integrate both sides, ds from s equals 0 to s, dt from 0 to t, and you will have the equation s equal 27t minus t cubed. Substitute t equal 3 in the equation to find the distance, which is equal to 54.0 meters. Result and discussion. Nothing was given regarding the initial displacement and time, so it were considered as 0. It was understood from before it stopped that the final velocity to be 0. Final time should be found to help in calculating the distance. Conclusion. Because of the acceleration, which is given as in the problem as a function of time, it should be integrated to find the velocity and then integrate the velocity to find the distance. Acknowledgement. The author would like to acknowledge the finding from the Higher College of Technology, the United Arab Emirates. And this is. Thank you.